Hello Year 9s, today we're going to move on to a new topic. So we're finished talking about standard form. I know we didn't spend very long on it, but that's absolutely fine. Today we're going to move on to a new topic called Pythagoras Theorem. You may have heard people talk about Pythagoras before. He was a famous mathematician from a long time ago. We're going to learn what his particular theorem is today, and his theorem has to do with right-angled triangles. So if you've got your exercise book at home with you, could you go ahead and write down the date and the title? So the title today is Pythagoras Theorem, and the date is the 27th of April. So you can go ahead and get your page started. You could also do the starter in your exercise book or on whatever piece of paper you're working on, or even if it's just on a whiteboard or some scrap paper is absolutely fine. So you go ahead and do that, and then maybe press pause on this video, and then I'll show you the answers, okay? All right. All right, here are the answers to the starter. You can always email me if you think I've made a mistake. Let's be honest, I do that quite a lot. Or if you have any questions, you can also send me an email to let me know. I generally try to put my email address for school in all of the things that I post on ePraise. All right, there's the answers. Let's get started with today's lesson. So one of the really important words for today's lesson and for the rest of the week is the word hypotenuse. So I don't know if you've ever heard the word before, but hypotenuse is the word that is in blue and has been underlined, and it says the hypotenuse is the longest side in a triangle. And we are specifically going to be talking about right-angled triangles. So all of our triangles are going to have 90 degrees in them somewhere, and the hypotenuse is always exactly opposite to the right angle. So in each of these 4 triangles, we're going to try to find the hypotenuse. So for this very first triangle, here is the right angle right there. If I want to find the longest side, it's always going to be opposite to the right angle. So if I'm standing here at the right angle, I can walk directly across. So this side over here where I've ended up, side C is the hypotenuse. So side C is the hypotenuse on this triangle. If I go to this next triangle, there's the right angle. And if I go directly across, side B is the hypotenuse on this particular triangle. All right, down here, here's my right angle. Again, if I walk completely across, directly across is side A. So side A is the hypotenuse in this triangle. And down here at the bottom right-hand corner, I've got the right angle, and if I go directly across, that is going to be side B. Side B is the hypotenuse. So each of those letters that I circled is the longest side in the triangle. That's going to be really important in the next few slides. We're always finding the longest side. All right, so here is our major new content for today. I promise it's going to sound way fancier than it actually is. Just trust me on what I'm going to tell you. So this says for a right-angled triangle. So all of our triangles today are going to have a right angle in them. Here is my right angle in this particular triangle. It says for a right-angled triangle, if I take 2 of the sides, I'll tell you a little bit more about that in a second. It says if I take one of the sides, sides A, and I square that, and I add on side B squared, I'm going to get side C squared. Now, I'll tell you a little bit more about that. The only thing that's super duper important, maybe it would be a good idea if you wrote this down, what's in the red box here, is side C is always the hypotenuse. That is the only particular rule when we do Pythagoras, is that the side C is always the hypotenuse. So that means this side here has to be side C in my triangle, and side A and B are just the 2 other sides. So I'm going to call this side down here side A, and this side over here side B. So I've got A squared plus B squared is going to equal C squared. You're probably thinking, what is she going on about? But I promise in the next slide, I will actually show you an example and it will hopefully make some sense. Okay, so maybe if you've got your exercise book or if you're trying to keep some notes, it would be really good if you wrote this down as an example in your exercise book. If you wrote down what's in the red rectangle there, and then you also drew the picture beside it. All right, so you go ahead and do that. Press pause while you do that, and then I'm going to go ahead and explain the next example. All right, here we go. Calculate the length of the hypotenuse. So here's the hypotenuse right here, side C, because here's the right angle, and directly across there is the longest side. So we've got one side down here, which is 3 centimeters. I'm going to call that side A. And I've got another one over here, which is 4 centimeters. I'm going to call that side B. So just a moment ago, we learned that A squared plus B squared equals C squared. So that must mean that 3 squared from side A plus 4 squared from side B ends up being C squared. So 3 squared is 9, 4 squared is 16, and when I add them together, I'm going to get 25. Now, I'm nearly done, but I promise you this side here is not 25. That is a really quite big number. So if I want to find out how big side C is, because I squared everything in the question, took everything squared, what I have to do for the very last step is take the square root of 25 to find out how big that is. So my final answer here is 5. The square root of 25 is 5. Side C is 5. All right, we'll try another example. Hopefully I didn't go too quickly in that one, but we'll try another one. So same idea, calculate the length of the hypotenuse. Here is my right angle. So directly across from there is side C. They want me to find out how big is side C. So I'm going to call 8 centimeters side A, and I'm going to call 6 centimeters side B. All right, so here we go. We've got 8 squared plus 6 squared. So that gives me 64 plus 36, which is 100. Remember, that's not the actual answer because in this question, in order to get these, I had to square these numbers. So now I have to take the square root of 100 to give me 10. So that must mean side C is 10 centimeters long. All right, and that is how we use the Pythagoras Theorem. Let's try one more question together. All right, last example from me today. Again, it says calculate the length of the hypotenuse. So here's the right angle. They've already filled that in for us. And directly across from there is this side here. So they want us to find out how big is this side here. It doesn't matter what I call the other two sides. I'm going to call this one side A and this one side B. So I'm going to do 9 squared plus 4 squared. That is 81 plus 16, which is 97. Now, the hypotenuse is not actually 97 because remember, I had to square my numbers to begin with. So in order for me to find out how big the hypotenuse actually is, I have to take the square root of 97. Now, I know we all think that usually I'm pretty good at maths, but I have no idea what the square root of 97 is. So sometimes you're going to get square numbers like in the last two examples, and sometimes you're going to have to use your calculator, and that is absolutely fine. So for this question, I'm going to use my calculator. The square root of 97 is 9.8. Okay, and that's it. That's all you have to do, and the whole question is finished. So that is the Pythagoras Theorem. I'd like you to have a go at the questions on the next slide in your PowerPoint, and the answers are all at the end. Okay, have a good day.